research I currently did with a couple of my colleagues, Vincenzo Ciancaglini and Robert Mercado. We all work for Trend Micro Research. And the research is called HTTPS-based clustering for assisted cybercrime investigation. So it's on the borderline with web security. So what I will show you is a system that we design to help our security analysts to do investigation. So nowadays there are a lot of target attacks, and they're pretty difficult to detect them in automated form, and there was no actually previous research in that field. So we invest some energy in trying to build a tool that can do in a kind of semi-automated form. So we'll talk about, these are the ingredients for today. So we'll talk about target attacks. We'll talk about how to analyze HTTP trace, such as GET and POST request of our customers to try to find this target attack in semi-automated way. So briefly, who am I? So I'm Italian, as you can understand from accent, but I live like most of the last 7 years abroad, and I work now for Trend Micro Research, and we do research in different fields, range from web security to malware to privacy and so on. So the roadmap for today is this one. So I give like an introduction on what is a target attack and what is the difference between target attack and traditional, conventional, widespread attacks, and what are the problems in detecting this attack, and why there is a need to detect this kind of attacks. And then I will present the system that we designed, that we call Sponge, a system that, as I said before, we use to process thread information collected at client side from our population of machine. The experiment we actually run to prove that the system works, and we conclude. So security is hot nowadays, so it's a good field to work on. So we are all pretty busy working security, and I would say that it's actually burning. So if you look at Symantec Internet Security Threat Report, even if the spam volume is constantly decreasing over time, we have a bunch of other problems. So web attacks are probably the problem number one. So last year we saw a rise in web attacks about 30%, with more than 5,000 new vulnerability discovered on a year. And what is interesting that there are a lot of new phishing attempts that are targeting social networks, both on mobile but on traditional desktop. So that's probably an interest for our attackers. And we had like a more than 40% increase in targeted attacks. So that means that attackers are more and more pushed to do this kind of attacks instead of conventional widespread attacks. So what is target? I mean, what do we mean for target attack? So we recently saw a huge shift from a world where there were widespread malware that was infecting discriminately everybody. So if you are male, or if you're female, if you're Italian, or if you're German, so they didn't care, you know. I mean, you just want to have as much more infection as possible, no? So we moved from that world to a world where the attackers are more target. They choose their victim, you know. I want to target, you know, some banks, and some banks even of Germany, only those banks, because they have something interesting for me. So we moved for a world where attackers were driven from curiosity, so just for fun. So probably the just for fun era is over, and it was over already 5 years ago, so now it's completely dead. To a world where the attacks are driven by either a criminal organization or by the nation itself. So we saw a lot of like nation-driven attacks, and the main goal here is espionage. Okay, so this kind of attacks, the goal there is to try to get access to the asset, be there in a stealthy mode, and get interesting information out of it. Documents of any kind, plans, or whatever. So probably one of the most famous like target attacks we saw recently was Stuxnet. So I mean, I guess all among you guys, if you work in security, you know what Stuxnet is. It's a piece of code that has been used to try to sabotage a nuclear plant in Iran. And recently, our Snowden friend, former nation NSA contractor, revealed that basically US, together with Israel, co-wrote this piece of software. So this is a kind of an example of target attack that is nation-driven, and we saw a lot of them. Another one is Red October. So Red October is not just a single target attack, it's an operation that was ongoing for more than 3 years and was targeting government organization, diplomatic organization, embassy, research institution all around the globe. So these are all examples of target attacks, so attacks that focus on a specific industry, on a specific target, and the main interest is usually espionage. And if you look at another AV company, Prigo Kaspersky Lab, they claim that target attacks only in 2012 cost more than £1.6 million to companies. So there is really a strong need to have like a system that try to help us in detecting this attack as early as possible, because this one was ongoing for 3 years, and you say, wow, you know, you are under attack in so long time and you didn't understand that you're under attack. I mean, something's wrong there, you know. So okay, so that's what we want to do, you know. So how can we at least try to detect these attacks in a semi-automated form? They're kind of difficult to spoil because they're difficult to distinguish from traditional widespread attacks. So the technology behind is the same. It can be a piece of malware that is sent by mail. It can be like a drive-by set up to exploit like our users. So there is not much about the difference from a technology point of view. The fact is that the methodology is different, so the way in which the attack is delivered and the target are different. So the target are specific to my target that I want to infect, you know, the target I want to target. So we start from here and we start thinking of a technique to kind of spoil this attack, and we came up with a tool that we actually are using nowadays to assist a cybercrime investigation. So the tool is generating every day a report that we pass to our security analyst, and the security analyst has something to start with, you know. It's like a crawler that help you to do a security assessment, you know. You start with a crawler. If you have a network that is a /8 with I don't know, thousands of machines, you won't do it manually, you know. You start with Nessus or Nmap, you get something, you know, that help you out to do the assessment. Here is the same. So we have this tool that analyze the data that we daily collect from million of users' machine that are using our software, and is able to reduce the number, the huge number of normal incidents that we see every day to a more manageable amount for further investigation. Okay, so that's the introduction of the problem, and here is the idea. So our idea is to look for those machines that have a common network behavior, so they behave like in a similar way from a network point of view, okay, because they are, for example, affected by the same thread, so they are targeted by the same guy, so they have, for example, they're running the same malware, or they are involved in the same botnet, okay, and we do it from a network point of view, the analysis. And then when we group this machine together, we have a group of similar machine, then we try to contextualize this machine. So we look at the machine and we say, are those machines like running in multiple organizations? Are those organizations involved, for example, in the same business? Which kind of business? Are maybe an organization, are for example banks, or are, you know, some nuclear plants down in Iran, or which kind of machine, of business there is behind this machine. So everything is summarized in the graph here. I'm going to go through that. So this is the general architecture of our tool. So it's like this. So we have like some events that we process on a daily fashion during nighttime, and we'll then talk later what are events, but briefly are just network traffic from this machine. And we pre-process them to be able to get rid of useless information, because there are really a lot of information and we want to be efficient as possible. So we only take those events that are interesting to what we want to do. We cluster them to create these groups of machines that are somehow similar, so affected by the same problem. And then we group together, and then we run the analysis at the end to look, for example, if in which organization these machines are operating, in which country, and so on. And then we come up with a report for our analyst. So let's start from the data set. So which kind of data we want to work on? So the data we work on are HTTP and HTTPS network trace, so that are collected at client side. So either on consumer machines, so normal end user, or on server, or also on, it might be even a proxy installed for the whole network, so it's proxying over everything, and we collect information there, really a proxy level. So we collect basically the URL that the machine are connecting to, either GET or POST request, and those ones are related to URL that we already know being malicious. Okay, so if a machine is connecting to this URL, it might be that because he received a spam email and the guy click on the spam and connect back to phishing site, or it might be that the machine is infected by malware, so it's connecting to the botnet, or it might be that the user is lured into visiting a site and download a fake AV and so on. So this is our data set. And we have a population about 20 million installation worldwide. And so you can imagine how much traffic is, okay? So the first things we do is to do some nice pre-processing of all this data. And we do 5 different processing here. So first we ignore all the parental controlled URLs, and we just keep those URLs that are malware related or phishing related or any kind of exploit kit related and so on. We use all the parental control URL. Then we do some sampling at class B level. So our granularity, you can specify, but as it is now, we have a granularity of class B. So if there are like multiple machines from the same class B that make the same request, we just keep one request. Then we do some event sampling. So if that means that if a machine is infected and is requesting the same malicious URL over and over, for example, it's because it's botnet controlled, we just keep like one record for that. Then we remove any duplicates. So if a URL is widely requested, for example, from more than 50 different networks, we remove it because we assume that this might be a widespread attack. So actually this is if you want, okay, here if you go higher, so if you specify 100 network, you will have probably less false positive, right? And finally, we learn from the past. So we run this process in batch mode every night, and if we see that some machine are not involved in target attack, or even some URL are not involved, we avoid to reprocess them the day after. So we learn from the past. So let's start. Okay, so do you have some question till here, or before I go into the detail, because it's getting a bit more. Come on, Nick. The 50 number, we choose it empirically. So, I mean, we can discuss about that, but if there are more than 50 class B networks that are infected by the same threat, it might be that most probably it's not a target attack, you know, because it's a lot. So if you are targeting organization, usually you target a couple of class B or a class A, but not 50. But you can tune it, you know. I mean, all these parameters you can tune it. So it depends from the capacity of your processing, because now the system now run on a single machine with 8 core, so it's distributed, but it's very easy to be ported to run on multiple machine. So of course, if you have multiple machine, you can tune, you can even get rid of this preprocessing, you can bring in everything. So in any case, you will have a result later on. So some other question on what we want to do, and is it clear? People are shy here, so okay, I hope it's clear. So the first step is clustering. So I don't know who among you is aware of what is clustering, but briefly, is a technique that is widely used in data mining and allow you to group together elements that are similar. Okay, so in our case, we look for pattern in the collect data, so in URLs, and we do clustering according to URLs that are similar on the host name or similar on the request in terms of path and query string, or both of them. So example is this. Okay, suppose you have like 5 domain, 5 host name. Okay, 4 are a typo squatting version of Craigslist, and one is google.com. So if you want to cluster this host name together, you compute the distance. Okay, so if you have like n host name, computationally you have n squared divided by 2 as difficult to say time to process it. So you compute the distance between this host name, and is a value between 0 and 1. So if you have 0 means the two strings, the two host names are very similar. If you have 1, is very different. No? So in gray here, you see that google.com is very different from the other. In fact, they have like a distance that is more than the threshold, but experimentally we set it at 0,4. Okay, so that means that these 4 host names, they will be grouped together because they are similar, and Google will be alone. This is the same example for URL used by 2 different exploit kits. One is black hole and one is nuclear. They are pretty famous. So as you can see, this exploit kit, they have a similar like request. So for example, black hole has a request of this form. Okay, so it's a PHP script with just a single letter, and a parameter are called F and E. And instead, nuclear is a jar with a long like ASCII file name. Okay, so here we same, we do some clustering on the request, and even if hosts are different, we can group together these 3 URLs belonging to the same cluster that we label as black hole, and these 3 to another one that is called nuclear. So the important things here is to choose a correct distance function. So it's a function that allows you to compute the distance between the host name. Okay, so if you want to measure, how much water is here, okay, you need something a distance function, a kind of distance function. In this case, is a liter. So 1 bottle is 1 liter. If it's more than a bottle, it's more than a liter. So here's the same. So for the host name, since the host name are strings, we use what we call standard distance function that is called Levenstein. So this function, for example, if you want to compute the distance between these 2 strings, Robert and Roger, so the distance here is of 2 because you need 2 changes to go from one to the other one. So the first one, you change the B with a G, and the second one, you delete the T. So the distance here is of 2. Instead, for the request, we use the Levenstein distance for the path, and for the query string, we use another distance function, very common, that is called Jacquard. So this one count how many parameters the 2 requests have in common. Okay, so for example, here you can see that these 2 URLs, okay, they have 2 parameters in common. Okay. So we ignore in this case the values because we often saw that exploit kit and botnet they have a value that change very rapidly. So if you bring the value in, it's very hard to cluster these URLs. We put together the path and the query string with this formula, and we have a distance of a request. So when we have the groups, okay, so the groups you can see it. So at the end of this process, you will see, you can imagine your URLs being organized in that way. So as a series of bubble, no? So you have like, I'm going from this side, from the left side of the audience. So you can see, for example, in red are those URLs that have been clustered per host name, and in blue those that have been clustered by request. So bigger they are, like the circle, means more similar URLs that are inside. Okay, so we have really two sets of different URLs, both clustered by host name and both clustered by request. Then there are some others, here. These two are violet. You say, violet? What's that? So these are URLs that have been clustered for both host name and both request. Okay, because they have, both are similar, So a URL that have similar host name and similar request. So in that case, so at the end of clustering, we have to run another process where we merge these two sets of clusters together, okay, to get rid of these useless clusters. So those ones that are, for example, one the subset of another one. For example, if you take the cluster 2 here in the middle, okay, this is a typo squatting cluster of Facebook. This one has been clustered, is labeled with H, means that is an host name based clusters. And this one is clustered because they have like a similar host name. If you look at this one, they have, this is a merge result of two clusters, one with a similar host name, it's very difficult to pronounce, and one with the same request. So these one have been merged together, and these two clusters become C3 in a single cluster, and these URL have both similar host names and similar requests. Okay, I don't want to spend way more time here, but the idea is pretty clear. So we have these malicious URL that are accessed by our machine, okay, and we look at the URL that are malicious and we want to group them together. Okay, so those URL are similar each other, this one are similar each other, this one here are similar each other, and here we are here at this step. Okay, so the next step is okay, so which machine is generating this request? Okay, so these are the URL. The question is, okay, so how many machines generate this request, how many machines generate this request, and so on. So we map the URL that have been clustered to the IP address, okay, to the machine. So we bring like the machine information inside. That means this column. So what I mean here for event is this, of course. So for example, when you do like this, then you can answer a question like the machine 1 to which cluster belongs to. So let's make a test. Want to answer here. What is machine 1? C1 and 2, exactly. So machine 2, C1 and 2, the same. So why we do this? Because when we know which machine to which cluster they belongs to, we can then understand which machine are similar. So they have like a similar network behavior, and this is what we want to do. So we want to know which machine are, for example, infected by the same malware, or involved in the same botnet, or they are reaching out to the same drive-by download site, or they are reaching out to the same phishing site, or whatever. So in the step 4, we group the machine together. And for example, in group 1, we have machine 1 and 2, okay, that share cluster number 1 and cluster number 2. Okay, so this machine they have some similarity among each other. Instead, if you take the group 4, there is just machine 6 there that is alone. Okay. So why one machine should belongs to 2 different clusters? So what's the use case here? The use case is this one. Take, for example, a drive-by download infection. So what happens usually is that the victim, okay, visit the malicious URL. Okay, the malicious URL, check wherever the victim come from, which kind of operating system is running, which kind of browser is running, which version of the browser, and then redirect the victim to a specific exploit. Okay, so if victim is reaching out with Internet Explorer, whatever version 8, you redirect to a page that contains exploit for that browser. So in this scenario, this victim will belong to a cluster of pages related to the redirection, and the cluster of pages that serve that exploit. Okay, so that's the case where a machine belongs to cluster. Finally, at the end, when we have this, we correlate the machine for the groups and for the cluster. So we do 2 types of analysis. The first one is cluster-based, the second one is group-based. So in the cluster-based, we look for each cluster, and we look for those clusters that might be interesting. For example, because they might be, they might contain machines that they all operate in the same industry. Okay, it might be, for example, government. So I might look, give me like all those clusters that involve machine in the industry, right? In the government, or maybe in the German government. Okay, so I can really look for those threats, those infections, those attacks that are targeted only to particular organization or group of organization, or only particular industry. Okay. And the groups one is basically an extension of the first one. So instead of looking just for one cluster, I can look for multiple clusters. So in the example I saw you before here, where you have like 2 machines belongs to 2 clusters, I can, group 1, I do the same query on groups. So give me all those groups of clusters with all those machines that have like a specific, I don't know, of a specific country, or under a specific internet service provider that belong to a certain autonomous system. I can query wherever I want. So as it is now, the system automatically look for those machine and cluster between 2 and 5. This value will make change for that with machine that are ever in the same industry. We have like 20 different industries, so ever the same industry, ever the same country, or both. So what's the result here? The result is we have this tool that we wrote in Python, and is running like nighttime. So we run every day. We collect like data from this 20 million like installation, and we process the data using a single server. And the processing time takes something like between 6 and 8 hours. And then the result is sent to another machine with a database, and this machine does the post-processing, the analysis. So basically correlate like the industry and the location information and generate a report for the analyst. So we made an evaluation over 1 week of data, and some of the findings we had are these 2 I'm going to present here. So the first one is related to an infection of a malware that infect 3 distinct organizations. That one is in Mexico, one is in Turkey, and one is Morocco. And the 3 organizations, they are manufacturing fabric. So they are classified as a technology sector, and they were infected by malware that it was injected into the memory space of standard Windows programs such as Notepad or SVHost. And this is a classic technique to keep like persistence of the machine, so to avoid like easy detection, and is often used when you want like to keep persistency there. And if you look instead at the IP address here, they all belong to a net block that itself belong to what is called the RBN. I don't know if you're aware of this. Is a Russian business network. So it's a network that is owned by some criminals that are known to provide support for targeted attacks. So you can basically rent the network and you can use it to deliver. You have all the infrastructure ready for you, you know, for hosting malware or CNC server, whatever. And here we were targeting 3 different like manufacturing companies in these 3 countries. And the next one is a bit more evident. So here is not just a single cluster, but it's 2 clusters that have been grouped together because both of these 2 organizations that are 2 oil and gas companies residing in Malaysia, they were both like involved in this botnet, and this botnet was controlled by malware that was malware customized for industrial environment, such as can be like an oil and gas organization, and the domain here, so this nucleardiscovery.com, was registered. If you look at domain tool, that is a service over the internet that keep like an history of a registrant for domain. You see that it was registered under the name of a Chinese guy that was also owning some other domains that were known in the past to be used in target attacks operation. So I'm not saying that the tool does everything automatically, but at least, you know, provide to security analyst a starting point for further investigation, and is able to reduce the huge amount of incident that we daily see from a lot of infection all around the globe, only to those ones that are, you know, more related to target attacks. And so to conclude, as Symantec has cited in his report last year, so we really saw like an increase in the number of target attacks. So there are more than 30% of target attacks last year. So there is really a need to come out with some tools, you know, to help the detection of these attacks. And as it is now, there are not really existing tools and not previous research has been done. So this is a first attempt that for sure has a lot of like problems, but with this tool we were able to spoil some of these attacks that are very difficult to do manually, because as I said before, the technology behind this kind of attacks are the same as the widespread one, so there is not big difference from a technology point of view. It's only the methodology that change and the target, so the victims that are different, are just some victims. The victims are not randomly chosen, but are actually very, chosen very carefully, you know. So with this tool that we propose, we look for those machines that behave the same from a network point of view, and then we look into the different groups, and we look for those groups that are interested because they contain machines, for example, that have that are infected by a certain malware and they run in a specific industry sector, can be, for example, oil and gas. And given our population of 20 million machines, if we see that just, you know, a group of 5 machines behaving that way, and all these 5 machines are, for example, of a specific industry, it might be interest to look at those, you know. So we want to have some future work here. The first is to have, instead of processing the data day by day during night time, we want to do it in a kind of online fashion. So that means that every day we enrich the result of the day before with some upgrade. So we want to do some GPU assisted processing to make it faster, and this should be pretty trivial to do. And third, we want to bring in some more feature, for example, either the process name or the process hash. So we now only cluster based on the host name or the request, so 2 features. But it would be cool also to bring in the process. So if we see, for example, that machine infected by a malware of the same family, or even that has the same hash, connect to 2 URLs that are completely different, okay? But we know that behind, the process that generates the request is the same, the same hash, or maybe of the same family. It might be that these machines are really infected by the same, malware, even if the URL they're connecting to is completely different. So we would have missed it without that piece of information. So yeah, that basically concludes my talk. So I think we have 5 minutes left. So feel free to ping me, to ask me question, or we can maybe meet tonight and I will be here. So thanks for listening, and I'm open to questions.
Thank you very much. If there are any questions left.
So everybody except Nick is allowed to make question here. So, but Nick can suggest to his friends. So, okay. Okay, Luca, go on.
So one question would be, is this something you could use also for a case like that, where basically the entire machine is coming silent for a long time, and was then employed immediately? So how does this work with if you can?
Yeah, the idea here is to, so Luca is asking with respect to Stuxnet or to a lot of target attacks that are hidden and stealthy for a long time and we cannot observe them, how this can help. So this help whether first we are monitoring that particular machine. So there should be a piece of software that is running there and is monitoring the network connection. So in our case is a proxy. So if there is a proxy, we can already see something, And if a malware that is generating some network activity, we might see something. If a malware instead is completely independent, disconnected from a network, so we can observe any activity from a network point of view, we are blind. But if it's actually reaching out, for example, a CNC server, reaching out another machine that is controlling using a backdoor the victim, at that point we see the connection, and if we see that there are connection coming only from a couple of nuclear plants, only from Iran, and not the rest of the world, of the globe, this system can detect it, because it's something that we are looking for. So we look for candidates that are interesting, groups of infected machine that especially that are circumscribed in a specific country or in a specific industry, especially the interested industry like government organization or energy sector.
Any other question?
So what would change in your analysis if you would have brought the country and the business category in early? So before, let's say, after we cover the bits, you start clustering on business, country business.
Okay, yeah, it might work. Yes, so the question is, so we do all the processing of 1 million of events, it takes like 8 hours, and then at the end you only look for, a certain business. So he's asking me, okay, why don't look for a business before, instead of doing all the analysis, and because it might be that there are some target attacks that are targeting some business that you are not interested in at the beginning, for example. Or you can do the other way around. You can bring in as a feature. Yeah, you can. That's a good idea. You can bring in as a feature as well, together with the host name and request and the process name, maybe even the business. So you can have like group together by machine by business. Yeah, make it worth a try probably. Yeah.
Marco, thank you very much for your talk.
Yes. Okay, thanks for listening, and hope you like it.
We have an announcement.